In this video, we're going to have a look at how to divide algebraic fractions. So when we are dividing algebraic fractions, there's two parts that we need to do. The first part is keep, change, flip. Now that refers to the expression in the question. The first part of the expression, the first fraction, we want to keep. We do nothing with it, it stays the same. Then the division sign gets changed into a multiplication. And then the second fraction is flipped. So the numerator becomes the denominator and the denominator goes up to become the numerator. So after I've done those three things, I've completed my keep, my change, the flip. Keep the first fraction, change the operation sign to a multiplication, and then flip the second fraction. So that is part one. Part two is to multiply the new expression. If you need a recap on how to multiply an algebraic fraction, go back and have a look at that video that explains how to complete this part. So let's now have a look at a couple of examples of how we divide algebraic fractions. In the first example, we want to divide 3xy over 2 divided by 4x over 9y. And the first step that I need to do is to complete my keep, change, and flip. So that is going to equal the first fraction I keep the same, so 3xy over 2. Then I change my division sign to become a multiplication, and then I flip my second fraction. So the 4x goes down the bottom, and then the 9y goes up the top. So that becomes 9y over 4x. So my new expression is 3xy over 2 times by 9y over 4x. Now I can go ahead and complete my normal steps to multiply an algebraic fraction. So the first step is to cancel any common factors. And I've got an x in my numerator and x in the denominator. Alright, go through and have a look. I've got two y's, but they're both at the top. I've got a 3 and a 9, but they're both in the numerator, and a 2 and a 4, but they're both in the denominator. So I can't proceed and do any more simplification. So now I go ahead and do step 2, which is to multiply my numerator across. So having a look at what's left, I've got a 3, a y, a 9, and a y. So multiplying that together, that is going to become 27y squared. And then having a look in my denominator, I've got a 2 and a 4 left. So that is going to give me a denominator of 8. So 27y squared over 8. I need to complete step 4, which is to check to make sure I can't do any more simplification. In this case, I can't. So my answer remains at 27y squared over 8. So let's have a look at a second example. In this example, I want to simplify the expression 8 over x plus 2 4x minus 5 divided by 2x minus 4 over 4x minus 5. So when I'm dividing fractions, the first thing I need to do is do my keep, change, flip. So I keep the first fraction the same, so that stays at 8 over x plus 2 and 4x minus 5. My division sign becomes a multiplication, and then my second fraction gets flipped. So my numerator comes down to become the denominator, and the denominator goes up to become the numerator. So it becomes 4x minus 5 over 2x minus 4. So my new expression is 8 over x plus 2, 4x minus 5, multiplied by 4x minus 5 over 2x minus 4. Okay, so now I need to complete my multiplication, and the first step is to check to see whether there's anything that I can cancel out. So I can put a bracket around my 4x minus 5 because I've got to treat that as one group, and then check to see whether I have any down the bottom, which I do. So I can cancel the 4x minus 5 in my numerator and 4x minus 5 in my denominator. Now I can check to see whether there's anything else that can be cancelled. And I've got an 8 and a 2. Now because the 2 is outside of the brackets in the second denominator, it is separate to the x minus 4 that's inside the brackets. So I can use that to cancel against the 8 in the numerator. So 8 divided by 2 is equal to 4. 2 divided by 2 is equal to 1. So now that I've gone ahead and completed all of my cancellations and simplifications, I can go ahead and do step 2, which is to multiply what is left in the numerator. And this time what is left in the numerator is just a 4. So that becomes equals to 4. Then I need to go do step 3, which is to check what is left in my denominator. And that's an x plus 2 and an x minus 4, both in brackets. So multiplying that together gets me x plus 2 and x minus 4. So before I finish, I need to go ahead and complete the fourth step, which is to check to make sure I can't do any more simplification. Because my 4 in my denominator is part of an x minus 4, I can't use that to cancel against the 4 in my numerator. So my answer to the question remains 4 over x plus 2, x minus 4.